Hello, my name is Daniel, and this is going to be a quick start guide for the HexGrids UE4 plugin. To start with, you want to go to your Unreal Engine launcher, go to your vault where you have your HexGrids. You can just search Hex to find it, and you want to install to engine. We currently support for 17, 18, and 19. Once the plugin's installed, you want to start either a new project or open an existing project. For this example, I'm going to start a new project. It can be a Blueprint or a C++ project. Once Unreal is opened up, you need to go to Manage Plugins. It might pop up down the bottom, or if not, you can go to Settings, Plugins, and in here, make sure Plugins is set, the HexGrids is set to Enabled, and if not, we'll restart. Once Unreal is booted back up, you can close the Plugins window if it's opened up, and to find the demo assets and startup content, firstly, I'm going to show the existing source panel, and then you make sure your view options and you want plugins enabled and engine content. Once you have this, you'll get all the engine plugins and engine content, and what you're looking for is the HexGrids content folder. In here, we have a HexGrids folder, and here's all the default folders. If you go to maps, there's a selection of maps to show some example content, such as if we open up the demo room. The demo room shows a walkthrough of a lot of different functions and simple ways to set them up. So we have the shapes, we have examples of flood fills and another flood fill. We've got movement ranges, single rings, line drawing, pathfinding, abstract uses such as driving sine waves and ripples, neighbors, diagonals, corners, and rotating around an axis examples. And in the last room, there's an example of A-star pathfinding being used to drive a character. Okay, if you open up the multi-instance example, this level shows how to use an instance grid. So you use instance static mesh components, but using multiple components to be able to use different meshes in conjunction on the same grid. The overview map is just an overview with some text and change notes. The runtime builder map shows an example of how you can build grids at runtime. If we start this, then we press tab to unlock the mouse and we'll start the grid builder. Now we can fly around and we can click to place grids, and you can see roughly how you might place a grid at runtime, whether this is something you give to users or use it to build your own custom shape maps. Once you're done here, the example shows how you can save the map, and this save is persistent. It writes to Unreal save files. So if we start a grid builder again, and this time we will load the last grid. And it shows an example of how you can animate the grid coming in. It also has the ability to remove tiles and place tiles, and you can change what tile you're placing. And this is just an example. You're definitely going to want to set this up to your specific map design with your own custom tiles, but this is just shows how it can be done. Lastly, in the showcase map, this map shows kind of just a very abstract way of animating tiles in different ways to kind of achieve unique effects. So this is all mostly using just two components to animate them, and using different selection methods such as the circle selection, spiral selections, movement ranges to select tiles in different orders and then animate them. If you want to get started with your own map, we'll start a new level, and you'll want to go to blueprints, and here's all the blueprints that come with the project. The main one you're going to want is the HexGrid. This is a great starting point for HexGrids. Place this down. I'm just going to set the light source to mobile to get rid of the non-baked lighting issue. And in the details panel, I'm just going to make this a little bit bigger, We've got lots of different options. So we can change grid shapes between rectangles, hexagons, triangles, and parallelograms. We can center the grid. This only applies to grids that aren't always centered, such as so rectangles and triangle grids can be centered. Oh, sorry, parallelogram and rectangle grids can be centered. And it defines where the start point is. So in this grid, the 0, 0 coordinate is in the middle when it's centered. If not, it's on the bottom left. I generally like centered grids. It makes things a bit easier to work with, but depending on your coordinate order, it's up to you how you use that. Next thing is the grid scale, and this controls the spacing between tiles. So this is how the grid, so the coordinates 0, 1, 0, 2, 0, 3 are scaled up to create a world space grid. So if we increase these, I'll explain that in a second. Changing just the Y for now, you can see the grid scales outwards and evenly. So if you're using different sized tiles to me, then you just need to tweak the Y. If you're using non-hexagonal tiles or hexagonal tiles that are not mathematically perfect, then you can untick the calculate grid X size. If you disable this, then we can manually set X and Y separately. But if you have a perfect grid, then you might as well just have it lay it out for you because it gets the maths correct. Use instances is up to you. If it's using instances, it's going to be much cheaper to run. You'll be able to build much bigger grids without so much of a frame rate hit, but you don't have the same flexibility as static meshes. Static meshes are much easier to work with. It's much easier to use different shapes of tiles. I do have the example for multi-instance grids, but the setup for that is relatively complicated. And when it comes to tweaking it and changing it and using it for your game, you might find it's just a very complicated setup working with multiple instances at once. So if you can work with static meshes, you will have an easier time. Per tile scale is just kind of a last minute thing to, if you just want to tweak the scaling slightly. This does not affect Z. Oh yes, it does affect Z. So you can use it how you wish. I nearly always have it set to 1, but it's up to you. Chance of mountains, chance of ponds is, I'll get back to that in 1 second. The grid size is how many grid you have in X and Y. So we'll go 10, 10. If you are on a hexagonal grid, because you're controlling the radius at this point, it'll always become very large. So lower your column size before you change to hexagonal. Also, hexagonal grids are even on all 6 sides, which means they do not use rows. Rows has no effect here. It's only the column, which is essentially the radius. So radius of 1, 2, 3, 4, 5, 6, etc., etc. Let's go back to 5. Now, chance of mountains, chance of ponds is an example of how you might seed the grid. So I'm just doing a completely randomized solution here. But you may want to write your own seeding system or use the runtime grid builder to build your own custom shape maps. But if this is just an example, if we case up to 0.6, you can see how it renders more or less mountains or ponds. We can change that 0.1, 0.1. Next, we will calculate grid X size, which we've been over. Water tile cost is to do with pathfinding. So if you're using A-star pathfinding or flood fill pathfinding, then it's going to have a travel cost across any tile. The default tiles have a cost of 1, and this is where you can say set a water tile cost. And the more expensive it is, the more the pathfinding will try its best to avoid it. So if you have a tile cost of 3, and there's a path that can get round that tile in 2 other tiles as a detour, then it will take that as its solution instead. Increasing this will make it more and more less likely to try and navigate through rivers or sand or hills. And again, it's just kind of an example of how you might set it up. If you have a look at the blueprint, you can see how you could adapt that to your own needs. Use per tile height variation is just another kind of random option. It variants the height of tiles. This doesn't affect any sort of pathfinding. The grid is still a 2D grid. But it's some way, if you were doing some sort of variation, if you were using it for building architecture or something else, Giant's Causeway style stone pillars, then you could add some variance here. And if you are doing that, then you can vary the height. I've got a random height variant here from -5 to +5, and you can just change that. And it'll just vary how random it can be. You can also find here meshes. In here is the meshes this grid currently uses and their materials. You can override these and just use this grid without ever having to go into blueprints if you prefer. Or you can do this properly. You can do this more in depth in blueprints. So it's up to you if you want to override it here. I've exposed it, but you don't have to use it. Debugging types, this is very useful. If we change to offset coordinates, then we can see how the coordinate structure actually works on this grid. So you can see with a hexagonal grid, coordinate 0, column 0, row 0, which is right in the center. And the ID numbers are generally relating to their either static mesh or instance static mesh IDs. If we change this to cube coordinates, then you can also see a cube coordinate variation here. So this center coordinate is obviously there's your X, Y, Z color coded. And some functions use cube coordinates, some use offset coordinates. This is just there should you need it. Axial coordinates is not currently supported in this plugin, so that doesn't do anything. We've also got a variable for splines. So if you're using pathfinding, you can use the spline system, which renders splines on the grid based on a pathing that was generated. You can customize this in the blueprint however you need, but here's just a few quick settings for nudging the height in Z to push it off from the grid, and the mesh size, which will be the spline mesh width. Okay, we'll take a quick look in the blueprint now, and it will just be an overview. We won't go over the specific nodes, but if you go to the event graph to start with, you'll see I've got all of the nodes, or at least the majority of nodes, commented with how these things can help you, what they're used for, etc., etc. And it's all broken down into various categories: selection methods, splines, corners and neighbors, converters, the pathfinding systems, finding coordinates of meshes through line traces, and some extra bonus stuff. It's worth noting that this bonus node here, get coordinates as world space, is not currently available in the plugin. It will be pushed to the Unreal Launcher quite soon. Okay, if we go to the construction script where all this happens, it's quite small and quite well laid out, I think. This plugin is a C++ plugin, but everything is exposed to blueprints. The C++ is majority maths and shouldn't really ever need to be changed. It's not like you need to go in to tweak anything specific. The maths isn't going to change. HexGrids are what they are. The maths for doing these things is fixed. So the C++ you should never need to touch. However, if you are a C++ programmer, then you can use all these functions in the code and build grids entirely there and not have to use Blueprint at all, if you like. So the basic setup here is if we're using instances, then we set up some instance settings. We clean up all old variables because this is a construction script and old variables can have a tendency to get messed up. So best to clear these things. That way later on when we do add to these things, we know they are empty. If we're using perfect hexagons, this is where that calculate grid X size comes in, and we perform a hex width calculation, which off the top of my head is the square root of 3 divided by 2. That's how it's worked out. And then we generate a grid. So taking the grid shape, we build a grid array, and this outputs a array of offset coordinates. And offset coordinates are purely a struct of columns and rows, which are both integers. Doing it this way is a nice tidy way to do it rather than using int points or floats, because floats will have the rounding variations. So this just gives you nice absolute grids. And these grids are going to be like 0, 1, 0, 2, 0, 3. So they don't have any world scaling to them. These are raw grids. So the grid itself you cannot use to place meshes, but we have nodes to convert this grid then into world space versions, which you can see in a minute. Once we've got a grid, we loop through the grid, and we either add instances or we add static meshes, and then we set up our debugging. If we have a look in the static mesh one, this is where it's going to be most important. So we're looping through the grid and we're passing in the specific grid coordinate each loop. So then in the static mesh, we store that coordinates. We store these as clean tiles because we know there's nothing on them just yet. Let me just clear that watches point. Okay, and then we add a static mesh component. The way we set the transforms up, specifically the location, is we take that coordinate we're currently on and we pass in the grid scale calculated, which if you remember was the grid scale with, which was the grid scale and with it auto calculating X if you choose to. Okay, and then we pass this into a scale and offset node. And what the scale and offset does is a C++ node, but it takes the coordinates and multiplies them by the vector. It's fairly straightforward as that, and it outputs a relative location, which is the one you care about, and also an offset coordinates. Now the offset coordinates may be useful, but because the scale and offset is going to return a float, and when it gets converted back to offset coordinates, it'll be rounded. It's not going to be absolute, and if you use this to build a grid, you'll see small variations in grid spacing. So it's best to use the return vector, which is a vector 2D, and in that way the values can be much more precise. We also apply the per tiling scaling if you need it, and rotation if you wanted to do rotation, if you need to do rotate your grid by 90 because you're using flat top hexes rather than pointy top hexes, then you can apply it here. Once we've built the static mesh components, we build a static mesh map, which is just a map of offset coordinates and then the static mesh component it relates to. And I do this quite a lot with these maps, and these are really handy because at any point you can go, oh, I need the mesh at 5, 7 coordinates. All you have to do is you can run a find, you pass in your offset coordinates, 5, 7, and it's going to return the static mesh that exists there. So if you're not using line traces, you have absolute coordinates in mind, then you can use this as a great way to get back your mesh components based on the grid. And you can always run the system backwards. You can, instead of doing find, you can get the values, and then you can find item, and then from there you could get the keys, and you could get to run the system backwards. If you had the static mesh component already referenced, perhaps from a line trace, you can trace it back to the key it relates to. Unfortunately, Unreal doesn't have a built-in find directly from here to find values. If you're doing C++, it does. Okay, then we choose the tile type, which is how we seed the system currently, which is purely a randomized system. It takes a random value, random, random. If it's true, it makes it a mountain. If it's false, then is it true to become a pond? If true, if not, just stay as the normal basic mesh. And what you want to be doing here as well is setting up your costs. So if we have a look at generation variables. It's here, grid storage is where we store lots of these things. And one thing we have is the tile cost map and the tile blocked set. So the block set is a set, obviously, of tiles that cannot be transversed under any circumstances. So they are mountains, or they are holes in the world, or it's ocean, and it's something that the pathfinding system can never use. And if you have specific types of units, you may want to have multiple block sets so that you can have a block set that only relates to characters that walk on land, characters that fly through the air, characters that move on boats, and it's up to you to adapt that as you need for your game. Tile cost map, similar, it's an offset coordinate map to a float, and the float is the cost of traversing that tile. These two maps, the blocked set and the cost map, are fed into A* and flood fills whenever you use them. You also want to remove these items from the clean tiles just to keep the clean tiles as something that works. We're not currently doing it here, but that's a mistake, and I've been meaning to append it. And this will be in soon. I'll be making this change along with the node I showed you earlier as published to the launcher soon. Once we've done that, we'll go back to our static mesh. We also create a dynamic material instance for those meshes. You certainly don't have to. I'm using it for different reasons, mostly for like selecting tiles if I didn't want to use splines. If you wanted to like have some sort of overlay that makes the tile go slightly whiter or green or something when you mouse over it, you can use this dynamic material instance to do it. And again, we're storing these in a map against their offset coordinates. So that is the workflow of how the construction kit runs. Just a quick note, there are some very handy functions. Either the functions listed in Event Graph, obviously extremely handy, and nearly all of these are shown in the demo room and how you can set them up. There's also functions that are just built in this specific blueprint that you may want to use, such as in utility, get static mesh at coordinates. And again, these are shown in the Event Graph as well. But these are quite useful for passing coordinates, getting in meshes near mice, and these are just shortcuts to what I've already shown you, finding the values from the maps. And that is basically it. So the system is very flexible. If you have a look at something like the multi-instance blueprint or the showcase map, then you can see lots of great examples of kind of more complicated setups. You can find it here. Like in the event graph, you can see we're just doing a cascading function using different things. And that'll be it. So thanks for watching. If you have any problems or need some assistance, have a look at my Discord channel, which is linked in this video description and also in the Unreal Marketplace description for this plugin. I'm check it every day. I'm giving lots of advice there if you need any help or you want suggestions as to how you might approach a specific problem. So please join me on there. Thank you.